This is question 28. This might be the topic that's come up. I don't think I've mentioned anything new that we haven't discussed previously. Maybe a little different angle on it, but I don't think there's been any topic that I mentioned that we hadn't seen previously. This might be the first example where we have an idea that just has never come up in a problem in class. It relies on things that you know either from Algebra 1, Algebra 2, Pre-Cal, or some combination of those. It's the idea of inverses and inverse functions. Which is what they're talking about here. I hate them calling this G. I wish they would just call it F inverse the whole time, because you got to jump back and forth between the names. Anyway, the really important thing to remember about inverse functions, and I'm going to draw kind of a generic one here. So let's say I've got a function that was doing this kind of thing, okay? Maybe it goes through the point 3, 0, and goes through the point, let's say this is the point 5, 2 over here. Remember what an inverse function does, okay? Going back to, I guess, Algebra 2. An inverse function switches the input and the output. And so really your x and y coordinates switch. So if you're going to draw the inverse of this, if this is your function f inverse would have the point 0, 3, which would be right here, and it would have the point 2, 5, which would be somewhere here. And remember, the inverse function will just be symmetric over the line y equals x, because you're flip-flopping x and y. Okay. Anyway, here's the connection from a calculus standpoint. They're asking us to find a derivative, which means they're asking us to find a slope. Okay. If I pick a point here on the curve, let's look at the point 5, 2. The point 5, 2 matches up with the point 2, 5 over on this other curve. Okay. If you notice, this slope here is not the same as that slope there. Okay, the x and the y coordinates change, but the slopes change. But if you think about it, I don't know what the slope is, but let's say the slope is 1/3. Okay, that's a change in y over a change in x. Okay, if you have an inverse function, instead of it being a change in y over a change in x, it becomes a change in x over a change in y. So if this slope here is 1/3, and you flip-flop all your x's and y's, when you find your slope here, this slope here, which I have drawn horribly, probably looks something kind of like that. So notice that's not very steep. That is pretty steep. That would be the slope 3/1. Okay. For the corresponding points, the inverse function's slope will be the reciprocal of the original function. But you have to be careful. Notice this isn't the slope at 5 and 5. One is the slope at 5, and the other is the slope at the corresponding x value of 2, because x and y got switched. So the two things you have to figure out. You have to figure out what the corresponding points are, and then you have to find the slopes at those 2 points and flip the two, okay? And if you notice here, they give us some slopes. The slopes are all based on function f. So we're going to have to find a point on function f, and then figure out where that corresponding point would be on f prime, on f inverse, and flip the slope. So those two things have to happen. All right. So anyway, I just made this up. This has nothing to do with that problem. But that's the background you need from Algebra 2 and Pre-Cal to be able to do this problem. So again, draw pictures. Okay, it'll make your life so much easier in these problems. We know that this function here, this is f, goes through the point 315. Okay, so it's maybe up here somewhere, and we know it goes through the point 6,3, which is oh, that's interesting. Let's see, over 3 up 15. Okay, over 6 up 3. So maybe something like that. Okay, so here is function f. Okay, so we've got the point 315 and we have the point 6,3. Okay, and that's our original function f. Okay, function f inverse. Let me make sure this is on the screen. It is. F inverse is going to have the point 3,6, which might be like right here, and it's going to have the point 15,3. Which is going to be over maybe something like this, okay? And technically this is going to be a reflection over y equals x of this, but I don't think that's super important for this drawing. Anyway, but this is f inverse, which they're calling g, okay? So they want me to find g prime of 3, okay? So what I need to figure out is, because again, I don't have any slopes here. My slopes are based on this graph. Okay, so I need to figure out, for an x-coordinate of 3 on a graph over here, where would that corresponding point be on the graph over here? Okay, so that'd be the point 3,6, which corresponds to the point 6,3 over here. So I need to figure out what the slope is when f is 6, not when f is 3, okay? So I need to look for f prime of 6, which they tell me is -2, okay? But remember, you switch the x's and the y's between the original function and the inverse function. So if a slope is a y over x for this, you're going to have to flip that. It's going to be an x over y. The slope at the corresponding point over here is going to end up being, so the point 3, 6 corresponds to this point down here of 6, 3. The slope here is going to be the reciprocal. It'll be -1/2. Okay, so again, it's weird because you gotta figure out that your x's and y's have switched and figure out what point on the inverse matches up with what point on the original function. Find that slope, and then you have to flip it to find the slope of the inverse function slope. So again, not a lot of calculus there, just knowing that, that a slope is a derivative. A lot of pre-cal there, or algebra 2, or stuff coming, I guess, from both classes.